Welcome, friends, to another session of What, Why, and How by Stats SD. The topic of our today's tutorial is arithmetic mean. It is in continuation of part 1, where now in the second part we calculate arithmetic mean using direct and indirect methods but for group data. To understand what's group data, let's look at an example. Before we understand group data, I will simply summarize that arithmetic mean is an average of the numbers in a data set. It signifies the central tendency around which most of the observations would clutter. So it becomes an important measure to summarize the data. Now, coming to the calculation of arithmetic mean, if you look at the diagram, we already calculated arithmetic mean for ungrouped data without frequency and with frequency using the direct and indirect method. By default, group data includes frequency. So we have only two methods, direct and the indirect method. Now to understand what's group data, let me give you an example. Here's a table where we have some observations X in a class interval 10 to 15, 15 to 20. If you notice, 10 is the lower limit and 15 is the upper limit. If I have to describe X, you can describe it as, say, marks of a student, marks of students for an examination up to 50 marks. So, set of students who score between 10 to 15 would be mapped in this class interval. Similarly, students scoring 15 to 20 would be mapped in the second class interval, and so on. Now we have f, which is the frequency, which means that in the first class interval, 11 students have scored marks between 10 to 15. If you notice, there is a continuation of the upper limit and the lower limit, that is 15, 20. This is an example of an exclusive class interval where the number 15 or the upper limit is excluded. So a student scoring marks between 10 to 14 would be included in the first class, and a student scoring 15 would be included in the second class. To calculate the mean, we have a formula summation fm upon n. If you notice, it's the same formula except fx we have fm. To understand what is m, m is a mid value of the class interval. Now, how do you calculate the mid value? It would be the average of the upper limit and the lower limit. In our case, we have 10 plus 15, which is 25 divided by 2, which would be 12.5. For the second class, it would be 17.5. For the third one, 22.5. So let me calculate. So here we have 10 plus 15, that is 25 divided by 2, that is 12.5. And when we multiply 12.5 with 11, we would get summation fm. So in this case, say it is 137.5. In this case, this would be, say, 17.5. That is the average of 15 plus 20 divided by 2. And when you multiply 20 with 17.5, I should get 350. So you need to complete this table. For your benefit, I have already done this. If you see, I have calculated the mid value for each class interval 12.5, 17.5, 22.5, 27.5, 32.5, 37.5. My next step would be to calculate the column FM, that is 12.5 into 11, 20 into 17.5, 35 into 22.5. So this column gives me the product of the frequency and the mid values. If I take a summation of Fm, it adds up to 2310. So let's look at the formula. The formula says summation Fm. So let's calculate for this class interval. So summation x bar is equal to summation Fm, that is 2310 divided by n. Please remember that in terms of table where you have frequency, n is equal to summation f, because we don't have only 6 students but we have 100 students. So if I divide 2310 by 100, my mean would be 23.10. So this is the direct method. So you would have to first calculate the mid value of the class interval. So taking, say, the third class 20 to 25, if I add them up, it is 45 and I divide by 2. So my mid value would be 22.5. So I hope you've understood the direct method. Now let's look at the indirect method. Now in the indirect method, there is a slight change. If you see, rather than finding, after finding m, I would also find deviation, which is denoted by d. And d, the formula for d is m minus a upon h. Let me explain what each alphabet stands for. M is the mid value of the class interval. So we have already calculated 12.5, 17.5. Now I assume any one of these numbers as my assumed mean. In this case, I have assumed it to be 22.5. In your calculations, you could use 27.5 or 17.5 or any other number. So let's do the calculation, and H stands for the class interval. The class interval is the interval between the lower limit and upper limit. So if you look 15 to 20, it would include 5 observations. So the class interval is 5, which is the same for all classes. So let's calculate for D1. D1 would be M, that is 12.5, minus A, 22.5, that is minus 10. Why do I say minus 10? Because you are subtracting 22.5 from a smaller number, that is 12.5, and I divided by the h, which is the class interval, that is 5. Oops. Okay. So if I divide, my answer should come to minus 2. Similarly, 17.5 minus 22.5 should be minus 5 divided by 5. So minus 1. 22.5 minus 22.5 should be 0. 27.5 minus 22.5 is, say, 5 divided by 5, which is 1. Similarly, you would get 2 and 3. Our next step is not FM but FD. So minus 2 into 11 should be minus 22. Minus 1 into 20 is minus 20. 35 into 0 is 0. 20 into 1, 20, and so on. So I've completed the table for you. Have a look at this. Just to recap, first I find the mid value of the class interval. So for 15 to 20, the mid value is 17.5. Now I find D, which is the deviation, M minus A. So for the second observation, 17.5 minus A, which is the assumed mean, is minus 5 divided by 5, that is minus 1. So once I calculate D, I find F product D, that is F into D, and I take a sum total of FD, which is 12. Now the formula for the indirect method, or also called as the step deviation method, I will write it for you. X bar equal to A, which is your assumed mean, plus summation FD upon summation F or N, but don't forget to multiply with H. What was our assumed mean? We assumed it to be 22.5. If you see, it has been highlighted, plus summation FD, which we calculated was 12, divided by summation F, which is 100, multiplied by H, which is your class interval, that is 5. Let's do the calculation. 22.5 plus 12 divided by 100 is 0.12, multiplied by 5. And if I do this, I would get the answer 22.5 plus 0.12 into 5 is 0.6. And my x bar, which is the mean, is 23.1. If you notice, the answer is exactly the same using the direct method or the indirect method. The choice is yours to use the indirect method or the direct method. I would suggest using the indirect method when you have very high frequencies. So if you multiply say 110 by a particular mid value, the answer may go in 4-5 digits, whereas the deviations would reduce it to either 2 digits. So I recommend using the indirect method. Hope my explanation was clear. If you if you have any specific suggestion or you would like to clarify your doubts, you can always drop a message in the comments section. Thank you and see you for another session on Median. If you like my channel, please give a thumbs up or subscribe. Thank you.